In this video, I'm going to show you how I kind of decipher between all the methods of solving a system of linear equations. Now, there are three types of methods for solving, and I want to discuss what each of those three are. So the first method that I have taught in my class is solving a system of equations by graphing. And I just kind of want to discuss what graphing entails. So if you're going to do the solving for the system of equations by graphing, typically this is because you want a visual display. So I'm going to circle that because that's what kind of distinguishes this piece. So you want a visual display of your equations. So then this leads me then to my second type of solution set. So it's substitution. This was the second type of solving that I used for solving a system of equations. And normally when I use substitution, it's when I'm looking at the two functions and I don't need or want a visual display. I just need to do a little algebra work. And when I choose substitution, it's typically when one of the equations is already solved for one of the variables. Meaning you'll have x equal to an expression, or you'll see y equal to an expression. Or I would say it's easy to solve for one. Meaning like, maybe you'd have x plus y equals 2. It'd be easy to solve for an x, or easy to solve for a y. So that would be when I'm looking at my functions and I don't need to do a visual display, but I do notice that it's easy to solve for one of the variables, or perhaps it's already done for me. And then the third and final way that I showed my students in my class how to solve a system of equations, it was by this type called elimination. And when I use elimination in my class, normally it's when substitution looks like it's not really going to be an easy feat, or all the coefficients of your variables are numbers. And so I'm going to give you kind of a sentence phrase here. So when the coefficients are the same or opposite for one of the variables, or if it's not as convenient, you could multiply your equations to get them to be opposite signs. So those are kind of the three methods. So graphing, obviously a graph gives you the visual, but substitution and elimination are strictly just the algebra working of it. And so depending on what kind of coefficients I have, like if I have 2x and 7y or 5x and 15y, I probably wouldn't do substitution because it might be more difficult to solve for an x or solve for a y to substitute that expression into the other equation. So this is kind of how I determine that. Now the types of solutions you get, or maybe the answer that you would get, there are three types of answers. One of them is the easiest one. It's 1 point. And that would be labeled x comma y. Or you would get no solution. And this happens when your lines are parallel, or when you're doing your substitution or elimination. You can't maybe see specifically that they're parallel visually. This is when your variables cross out and you get 0 equal to a number that is not 0. Or, for example, the numbers don't match. So your variables are going to cancel out and you're going to go like 7 equals 5, which is definitely not true. And that would happen in your substitution or elimination. And then the third type of answer would be infinite solutions. And this happens when your two variables or two equations, so two equations like this, are disguised as two different lines, but they're actually not. They're the same line. And so I'm going to write that down here for you. So this would be same lines. And when you're going down through your solving, you're going to get 0 equal to 0, or the numbers match, essentially. So you don't get 0, maybe you get 5 equals 5, and that's always true. And so what happens in that case is that you'd have infinite solutions. So then here's just kind of my little diagram then to help you with systems of linear equations, just sort of the application part, so real world problems. Normally when I'm setting up equations, when you see how many, that means you want to keep your items together, like 7 pencils and 7 pens, and you purchased, or you're counting how many pens did I purchase if I purchase 152 pens or pencils. So keep your items together for one equation, and 2, keep your money together for the other one. Or if your question comes down to like cost and price, you would write each equation of the situation in standard form. That's very typical. And then lastly, comparing 2 situations for your best outcome. If you're given like a rate of change and a starting point, then you would be using slope-intercept form, and that's what that stands for, slope-intercept form, just kind of abbreviated. So stay tuned for the next few videos. I'm going to go through a bunch of application problems and then tell you which method I'm going to choose to solve, and I'm going to utilize these kind of 3 keys that have helped me to know how to write my equations out.